Here we're looking at compound interest, and the problem reads, Sandy invested $13,000 in a CD, that's a certificate of deposit, earning 3.4% interest compounded quarterly. How much money did she have after 3 years? And we have a formula, and each of the parts of the formula has a meaning, and the A stands for the ending amount, so what you have at the end of your investment period. The P is your beginning principal, so the amount you invest. The R, which is here, is your rate, and it's for interest, and you have to show it as a decimal. So you do have to convert from a percent into a decimal. And the N is the number of compoundings. In a year. And the T is time in years. So that's all the variables that you have in this formula. Usually the ending amount is the part you don't know, and you plug in the principal, the rate, the number of compoundings, and the time. Now for the number of compoundings, we have to think just a little bit more. I'm going to slide it up just a hair here. And if you have n equals 1, if you're going to use n equals 1, that would be for annually, because it's one time a year, and 2 times a year, or n equals 2, would be semi-annually. That's the word you would see in the description. N equals 4, that would be 4 times a year, so there are 4 quarters in a year, so that would be quarterly. 12, that would be 12 times a year, which is monthly because there are 12 months in a year. 365, that would be daily because that would be every day of the year. And 52, there are 52 weeks, so weekly. So if you have annually, you'll use n equals 1. If you have semi-annually, that would be n equals 2. Quarterly would be 4 times a year, monthly 12 times a year, daily 365 times a year, and weekly would be 52 times a year. Okay, so let's look back at Sandy's problem. And Sandy has $13,000 that she's going to invest. That would be her principal because it's the initial amount, and the 3.4% interest would be, I have to move my decimal 2 places to the right, so it would be 0.034, and that's going to be the rate. Compounded, there's our keyword that tells us we're going to see the value for n very soon. So compounded quarterly, quarterly means 4 times a year, so our n is going to be 4. And how much money did she have? That's our A. We don't know how much money at the end, so after 3 years, and in 3 years is going to be our T. So if we use all of those values here for our formula, the A is the part we don't know, so we'll leave it as an A. The P is 13,000, and then we have times the quantity 1. That's a freebie, it's just the number 1, plus R is 0.034 as a decimal over n, which is a 4, raised to the n, so we have another 4 times T, which is 3. So there's our formula. Now we would like to use a calculator, and remember we have to remember, or well, I should tell you, we have to remember the order of operations, which means that the very first thing you work on is parentheses, so everything inside the parentheses comes first, then the exponent, and then this multiply out front. So if we work inside the parentheses, we have to do the division before the addition. So let's start with the division. So we have 0.034, and then we're going to divide by 4. And if I just leave that on my calculator, I can use it here. it's going to be 1 plus 0.0085. And since I can multiply this in my head, I should go ahead and do that. It makes it a lot easier for me. 12 and 13,000 being multiplied as the very last step. So now, still working inside my parentheses, I have to add 1. So I just do plus 1, and then I get the 1.0085 raised to the 12th power times 13,000. Now I'll show you how I do this a little bit quicker in a minute, but for now I'm going to write down each step so that you can see what I've done. So I've taken care of all the operations inside the parentheses. And the next thing I want to take care of is the exponent, because that comes way before multiply or divide. So I will take care of the exponent, and that means I raise it to the power. So I'm going to use this y to the x button here, to the 12th power equals, and I get a nice long decimal. I want to keep all of that on my calculator because it's going to make sure that my answer comes out to the proper number of pennies. And normally I would not write all this down, but just for this first time I am. Now I've taken care of everything in the parentheses and the exponent, so now I'm ready to do the multiplication. So I'll just put in the times 13,000 equals, and now I have my answer. A equals 14389, and I need to round to the nearest penny, which is going to be this second decimal place. So I look at the one following, and since it's a 0, then I will leave the 8 as it is, so it'll be 78 cents. Now if the 0 were a 5 or higher, then I would want to bump the 8 up to a 9, but because it's less than 5, I will just leave the 8 as it is. So my answer is Sandy will have $14,389.78 after 3 years of her investment time. Okay, we have a problem here for you to work. Go ahead and pause and give that one a try. Okay, so I need to identify each part of my formula, and I'll rewrite the formula here for you. Principal times 1 plus the rate over the number of compoundings raised to the n times t, so the number of compoundings times time. Now this is my principal, my starting amount, the 400,000. My 2.7% interest translates to an R equals 0.027, and the 5 years will be t equals 5, for time is 5 years. And then we have 3 different banks, and they compound differently, so my n is going to be from whichever bank I'm looking at. So this is bank 1, compounds annually, so my n is going to be 1 time a year. And now I want to plug in, I have a P, an R, a T, and an N. So I have everything on the right hand side, so I'll go ahead and plug them into my formula. So I have A equals, P is going to be 400,000, and then I have 1 plus, my R is 0.027 over N, which was down here, of 1, raised to the N times T, which is a 5. Now I know 1 times 5. I should always calculate this first in case it's a difficult one. Sometimes you have 24 times 7 or some crazy number like that. So we'd want to multiply these first. That's just going to be a 5. And then when I look inside the parentheses, I can see that I can do all this in my head. 0.027 divided by 1 is just 0.027. And when I add 1 to it, I'll have 1.027 raised to the 5th power, and then multiplied by 400,000. Now that's all I can do on my own. Okay, I'm going to work this pretending I don't know the simple parts of this. So first thing I would do is multiply these out. So 5 times 1, and I get 5, so I would just write the 5 down because I'll need that in a minute, but I can't take it to the 5th power yet. I can just perform that multiplication and